Okay, Henry and I are here to do one more AP problem with you before leaving a problem in the video. This is from the 2002 AP test. And Henry, what shape do you see right there?
I see a conical shape.
You do. So before we even talk about the problem, what's the formula for volume of a cone?
1/3 pi
R
squared.
squared h. Correct. And this is the kind of where you'll have sometimes it'll involve radius and sometimes it'll involve height. And you probably don't want to use both pieces of info. So we look for a ratio between radius and height. Do they give us a ratio between ratio and height? Henry, do they give us the ratio of the height to the radius?
Yes, it's 1:1.
Look a little closer. You got the right idea. They threw one little trickaroonie on you. They said that when the height is 10, the diameter is 10.
Oh, shoot.
So
1 to 0.5.
h to r equals 10 to 5. You're right, but what's the relationship? The radius is equal to how much of the height?
1/2.
Radius equals 1/2 height. And what's the opposite of that? Then the height equals how much of the radius?
2.
2r. I don't know which one I'm using. I just wrote them both down because it's just easier to find them and then come back and deal with them later. We've got that there. The water in the container is evaporating so that its depth h is changing at a constant rate of this unit's right here, -3/10. So the question is, what rate of change is that -3/10?
That is the height.
Correct. It's the rate of change of height with respect to time. Here's the question. Is it increasing or decreasing?
Decreasing.
It says it right there because we've got our minus sign. I'm not sure what the problem's going to ask me about, but I would almost venture to guess that it's going to have something to do with these things we've just brought up. Let's break out the calligraphic pen. Do some good writing. There we go. So it says find the volume V of the water in the container when the height is 5. So first he wants to find the volume. So you already figured out that V equals 1/3 pi r squared h. Close that. There we go. So we want to find the volume when the height is 5. So it's V equals 1/3. Doesn't write very nicely. Pi. They said h is 5. Well, what do we know the radius is when the height is 5?
10. Or is it?
They're always going to throw numbers in to try to trick you. They're giving us the height. Just look over at our relationships. If we know the height is 5.
Oh, it's 1. No, it's 3.5.
Close. Say the relationship.
2.5.
2.5. There it is. 2.5. That answer right there, totally acceptable. We don't have to work it on out. We can leave it just like that. Okay, so we found that. Indicate units of measure. Ho ho!
They almost got us.
Volume is measured in what?
Centimeters per hour squared.
That would be a rate. This is just volume.
Oh, just centimeters.
Centimeters would be length,
Times height.
would be area. Volume is how many dimensions?
3.
Centimeters cubed. Okay. It says find the rate of change of the volume of water in the container with respect to time when h is 5. So they want dV/dt when h equals 5, and they want units of measure. I'm going to change this pen here.
Yeah, that stinks.
Let's try a thicker green one. See if that does us any better. So first I need a formula for volume, which I'm going to flip to another page to write this on down. And I'll just write right here. I know that V
Oh, there it is.
equal, look at that, 1/3 pi r squared h. I can take the derivative of that, Henry, but I got way too many variables in there. What variable do I really want to use? Well, they're telling me about h. They've given me the h dt. So I'd like to have everything in there in terms of h. So what is r equal to?
R equals 1/2 h.
So r squared is going to be pi 1/2 h squared squared. Okay, so now let's simplify that and combine things. V equals, whoa, Peter, what you doing there? 1/3 pi. What's 1/2 h squared?
H. Right?
Well, I got to square the 1/2.
Yeah.
What's 1/2 squared?
2.
Nope, 1/2 times 1/2.
1/2. 1.
What's half of a half?
I don't know. A quarter?
Yeah.
God, I hate math.
No, it's because there was recordings on. You don't want to be wrong when it's doing the recording. H squared times squared.
It smells even worse in here than usual.
Now I have to stop the whole video because I can't pause it in the middle.
Sorry.
No, it's okay.
Recording me?
Yeah, we're making a video right
Oh,
now.
I'm sorry. You have to send that out.
We'll keep using this one. Hello. So Henry, I'm gonna keep going here. V equals.
Is it still going?
Oh yeah, 1/12 pi
I'm so uncomfortable.
h squared. That's what V was equal to. I'm gonna bring this to a new page because this page is too sniffly. Needs more space. I'm gonna write it on down. V equals 1/12 pi h cubed. Let's take its derivative.
Okay.
What's the derivative of V in terms of time?
dv dt.
dv dt. T equals 3/12 pi h squared dh dt. Where did that 3 on that top come from?
That is 3/1.
Right, when I took the derivative of that 3, this pen is right nice, this thickness. I like this one. So that's our relationship right there. They want us to find dv dt. They asked us to find dv dt when h was equal to 5. So like, you free a marker?
Yeah.
3/12 pi h squared is 25. Oh no, I need to know what dh dt is. Did they tell me?
Yeah, negative 3/10.
The fact that you remembered it was negative 3/10, that's pretty darn good there, Henry.
Thank you.
Negative 3/10. That's what dv dt is. We do have to simplify it. It's a non-calculator one. So we would go there, but they asked me for units of measure. All we have to do, Henry, is look at this piece right here.
Derivative down.
Well,
Centimeters.
Here, what do you measure volume in? What do you measure volume in?
Centimeters. Cubed.
Centimeters cubed. What do you measure time in?
Hours.
How do they measure time?
Hours.
Hours, he's right. That's the correct information there. Now the last part is always extra tricky. Always extra tricky. And if you don't get it, it's okay. Well, let's take a look at what it says. It says show that the rate of change of volume, is directly proportional to the surface area of the water. What? The rate of change of volume is directly proportional to the surface area of the water? Let's write it down. What would be the rate of change of the volume? How do we write that?
dv
dv dt is directly proportional, that would be K, to what? To the surface area of the water?
which
How do we find the surface area is a circle?
pi r
What's
squared.
pi r squared? Well, I'm going to bring that with me to the next page for a second. Okay. And I'm going to write it right next to what we have right here. I'm going to erase this a little bit here. So Henry, you just found out, whoa, that,
I'm going to grab a drink. Hold
yeah,
on.
dv dt,
You still recording?
yes,
So long.
equals K pi r squared.
Your sweatshirt?
Wait, just wait for Henry to come back. He's taking his time now.
Talking to Andy.
I see that. So here's what we found before, Henry. We found this. And here's what we're saying is true. dv dt equals K pi r squared. They want me to figure out what K is. These two things look very similar. Let's see what they, dh dt, we know what that is. They fill that in. What was dh dt?
dh dt was negative 3/10.
It was negative 3/10. So let's see what makes these two equations similar. Hey, they both have a pi in them, don't they?
Yeah.
Okay, they both have a pi.
They
They-
both have DVDT.
They both equal to TVDT, but one has an H and one has an R. That's the problem for right now.
Well, 1H is half an R.
Oh, one H is half an R. You're right. So this is really equal to no H was 2R. Height was 2 radiuses.
Oh yeah.
Height was 2R. So let's get rid of those parentheses. dVdt. Let's turn all this into one little number here. This is going to come out as a 4. And this is going to be r squared. So how many new numbers do I have now? I have -3 times 4 times 3. I'm just putting these all together. This one, that one, and that one, and pi. Over 12 times 10. 20. R squared. Look how similar they are now, Henry. Here's pi r squared.
So does that mean K equals?
Whatever else we have left over right there. So we can even multiply that. That's 9 times 4 is negative.
27.
9 times 4. 9 times 4 is negative 36, like Henry said. Over 120 is our value for K. Last part's always super tricky. We're okay with that. Because you got through the 3 videos, I'm not going to add 2 problems onto the end. And I'll see you tomorrow.